Hi, my name is Karsten Kell, and I'm a Senior Manager of Product Management for AWS Service Catalog, and I'll be doing session MGT 302, Gaining Application Level Governance and Cost Visibility with AWS Service Catalog. So today, I'm going to give you a brief overview of how you can use AWS Service Catalog to balance agility and governance, and to enable self-service for your builders and monitor costs for Service Catalog products. I'll also introduce a new feature of Service Catalog and how it can help you gain application level cost visibility. So with that, I'll start off with how you can use Service Catalog to balance agility and governance. AWS Service Catalog sits in the suite of AWS management and governance services. We sit in the provisioning track, enabling governed provisioning of AWS services. The mission of Service Catalog is to enable customers to provide agility for their builder teams with the control needed for cloud centers of excellence and central cloud architecture teams, often for companies in regulated industries where these controls are really important for regulatory and compliance requirements. So how do you use Service Catalog? There are two main personas that use Service Catalog, administrators and end users. And the way Service Catalog works is that administrators, cloud administrators or cloud architects, create a set of AWS best practice products, and they put them into Service Catalog. So now they have a catalog of curated best practice products. These administrators then share these products with their builder teams. These teams can then in turn self-service, browse, discover, deploy, and manage the lifecycle of these products. So I'm going to walk through a little bit more detail of how this works to show you some of the additional features of AWS Service Catalog. So first, as I mentioned, the cloud administrators and architects create a curated catalog of products. They put those into what we call portfolios in Service Catalog. You can think of a portfolio as a folder that you put these products into. When you put the products into a folder, you can apply Service Catalog governance features. And I'll talk a little bit about some of these governance features. So one of the things you can do is add what we call constraints. There are multiple types of constraints. The most popular ones that we see customers use are launch constraints, where you can specify the role with which a product will launch. Now, this is important for role separation in enterprises. So you can provide a product to an end user. When they invoke that product, it won't launch with their privileges on AWS. It'll actually launch with the launch constraint or the launch role that the administrator has specified. So this enables you to provide different privileges to your end users, but still enable them to launch AWS Service Catalog products. And Service Catalog assumes that launch role on behalf of the end user when that product is provisioned. There are other types of constraints. Template constraints enable you to control the parameters that are part of the product launch. So for an example, you may have an EC2 product, and you may want to limit the types of EC2 instances. Instead of hard-coding that into a CloudFormation template, you can specify the specific EC2 instance sizes that you want that particular product in that portfolio to allow the user to select. So you can even have different portfolios where you might have a testing team that needs to choose different EC2 instance sizes than your development team or your marketing team. I mentioned CloudFormation templates. So a Service Catalog product under the hood is a CloudFormation template. We allow administrators to add some additional metadata to that, a user-friendly name, a description, a link to additional documentation, but a Service Catalog product can be anything that you put into a CloudFormation template. So you could do something simple, as I mentioned, like an EC2 instance, or it could be an n-tier stack or a serverless application that you specify in CloudFormation. So once you've done that, once you've created a product, put it into a portfolio, added the constraints that are appropriate for that portfolio, there are a couple of other things that you can do. You can add what we call service actions. So these are Systems Manager, AWS Systems Manager, automation documents, which could be runbooks or things that take operational actions on resources. You can create those in AWS Systems Manager, and you can associate those to a product in your portfolio. That product will then be visible to the end users, and they can do those operational actions. I'll get to that a little bit later. Product versioning. We support versioning of products. So you can continually improve your products, create new versions, but still enable users to use old versions if you choose. This is all administrator controllable. And a highlighted item here are what we call tag options. And this is going to be really important for cost visibility, and I'll get into that a little bit later. Service Catalog tag options are key value pairs. They get stored in the Service Catalog tag option library, and this enables administrators to specify their tagging taxonomy. So they can specify a single key and multiple values. And when a product is provisioned, the user has to select from those values, and they cannot change the key. So you can ensure that your tags are always properly spelled, and it's using the tagging taxonomy that's important for your enterprise. So step 3, once you've created the products, added them to the portfolio, and shared them out with your users, the users can self-service discover and provision those products. And when they provision them, it's done with all of the governance controls that I mentioned. It'll launch with the launch role that's been specified. It will invoke any of the template constraints, CloudFormation parameter controls that have been specified, and tagging will be enforced. So when the end user provisions this, it's properly tagged. They can use the self-service actions if those have been associated, and they can self-service maintain that product. They can do updates and terminations of that product, all without having to talk to an administrator or submit a ticket to have these operations performed on their AWS infrastructure. They can do it all themselves. And the admins can sleep well at night knowing that everything has been done in a governed manner according to what they've set up in AWS Service Catalog. And so now I'm going to talk about a couple of different patterns of usage. I briefly mentioned sharing earlier, and I haven't talked too much about that. So let me get into the sharing mechanisms that we have with Service Catalog. So once you've created your portfolios, you can share that portfolio account to account. So you can specify an account to which that portfolio should be shared, or you can use Service Catalog's integration with AWS organizations, and you can share that portfolio with your entire organization or with a specific set of organizational units. We give you the flexibility to do that from the top level of your org structure or from a delegated administrator organizational unit. So what that enables is you can pretty much decide how you want to share products from one organizational unit to any other organizational unit. And this greatly simplifies sharing across tens or hundreds or even thousands of accounts. We do have customers sharing Service Catalog portfolios with multiple thousands of accounts. Some patterns that we've seen for the sharing are, and I'm going to go left to right here, everyone gets everything. This is a very simple way to do sharing. The cloud administrators create a central catalog of products. They put those all into a portfolio, and that gets shared with everybody. So all your DevOps teams, your data scientists, they can just browse through those products, self-service provision them, and maintain the lifecycle of what they've provisioned. A more popular feature, and more popular in terms of we see a lot of customers using the middle pattern here, is what we call private catalog shares, where there's a central product list that the cloud administrators maintain, and they create portfolios for specific dimensions of their organization. A very common one is teams. So they may create a portfolio for their DevOps teams, and that portfolio will get shared with all of the DevOps teams in their enterprise. Similarly, they may have a data science portfolio or a marketing portfolio, and they will put Service Catalog products into those portfolios that are appropriate for those teams and then share them out. The third one we've seen is pretty interesting, and this is something customers came up with on their own, and it's a way to do a feedback loop and contribution model for Service Catalog products. So again, admins create a central product list. They share those out with teams, but those teams take a look at those products and they may use them as is, or they may want to modify them. And so what you do in that case is you set up a local team administrator. So it's just another Service Catalog administrator who can review and then publish those modified templates to the local portfolio. There could even be a feedback loop to the central product list. I haven't depicted it here, where interesting modifications to those products might be usable elsewhere in the enterprise, and that can get added to the central product list. So these are some very common patterns that we see with our customers, and it provides a lot of flexibility, creating well-architected, vetted products, and then sharing those out through your enterprise via different mechanisms. We even see enterprises using multiple sharing patterns that we've described here. So now I'm going to get back to tagging. And as I mentioned earlier, this is really going to be important for cost visibility. So I mentioned the Service Catalog Tag Option Library, where you can implement your tagging taxonomy, create a list of key value pairs, and you can specify a single key and multiple values. These tag options are associated with products and portfolios. So you can have a portfolio level set of tag options that you associate, and that might be appropriate, let's say, if you have a portfolio for your DevOps teams, and there's a set of tags that you always want applied for that DevOps team. You can also apply them to specific products. So there might be some finer grained tuning of tagging that you want to do at the product level. You can do that also. Now, when the end user self-service provisions that product, those tags will get enforced. If there are multiple values that are available, the user must select one of those values in order to continue with provisioning. So the net result is your Service Catalog provision products, which are CloudFormation stacks, are properly tagged. One other thing that I haven't mentioned yet is Service Catalog will also provide 5 additional Service Catalog specific system tags. We call them auto tags. They're always there. They don't count against your 50 tag limit, but you can use them. So we include, and I've listed them here, provision product ID, the product name, the provisioning principal, which is the user. And so these are tags that just appear on the Service Catalog provision product and any of the downstream resources that are provisioned. And you can key off of those for operational actions, for example. It turns out it's very useful to have that set of tags and to know basically the genealogy of where this resource came from on AWS as it was provisioned by Service Catalog. So that's all great, but what do I actually do with these tags to provide better cost visibility? So one of the things we've done in Service Catalog is we've worked with the AWS Budgets team, and we've created an integration between AWS Service Catalog and AWS Budgets. And it's based off of tags. So what a customer would do is create a budget based on a tag, and you could use whatever tags you want, or you could use Service Catalog auto tags. So if you wanted to track costs, let's say, by portfolio or by a product, you have those tags available automatically through Service Catalog tags, and you can create a budget based off of that. If you create a budget, you can associate that in Service Catalog with your Service Catalog portfolio or products. So I've got portfolio A, which has an AWS system tag that denotes portfolio A. I create a budget for that, and I associate it with that portfolio. At that point, Service Catalog will track that for you. So in our console, administrators will be able to see their month-to-date costs for the portfolio or product that they've created a budget for, along with AWS Budget's forecasts for that portfolio or product. So it's a straightforward way to get visibility into how much Service Catalog products and sets of products as defined by portfolios are costing you. So we haven't talked a lot about how the end users use Service Catalog products. And one of the really interesting use cases that we've seen customers use is to enable builder agility. So I'll get into this a little bit about how builders use the Service Catalog products that are provided. I've already mentioned a couple. They might go to the AWS Service Catalog console and click through and provision a product. Very straightforward, great for users who aren't even familiar with AWS. They can use Service Catalog to self-service provision products. You can also use our API and CLI We have APIs and CLIs for doing any of the actions that you can do in the console. And we also have something that are called CloudFormation resources. So you can actually embed calls to Service Catalog from within a CloudFormation template. So the way that end users use this is they just use the product directly, or they can combine multiple Service Catalog products. And this is a fairly recent feature that we've added to Service Catalog. So what this lets customers do is stitch together multiple Service Catalog products to create more complex products. And you can imagine this is great for DevOps teams who might not want to author a well-architected EC2 product or an RDS product. But let's say they're creating an N-tier web server and they want to combine an EC2 instance with an RDS instance. They can do this, and they can leverage Service Catalog well-architected products under the hood to do that. And they just need to do the combination. So I'll walk through these in a little bit more detail about what this looks like if you invoke a Service Catalog product from within a CloudFormation template. First, admins distribute the products. We've already talked about that. And here I've used an example of a simple API gateway product. And if a developer wants to use that and maybe add some of their own goodness around that API gateway, they can author a CloudFormation template. They can call Service Catalog via the Service Catalog CloudFormation handlers. And I've given an example here of what that would look like. When they provision through CloudFormation, that will create a CloudFormation stack. During provisioning, when CloudFormation reaches this call, it will actually invoke Service Catalog to provision that particular product. And that means that all of the Service Catalog governance that you've established still applies. So this is not a way to circumvent governance. This product will get launched with all of those constructs, the tags properly applied, but it gives the developer the ability to combine other things in their template with this Service Catalog product. So I'll get into a little bit more complicated use case where if I'm a builder, maybe I want to combine a number of these things together. So here I've given an example of an API gateway, a Lambda, and an S3 bucket. So as a developer now, what I can do is I have access to all of these products that my administrator has shared with me. They're all approved by my company, so I don't have to worry. I don't have to construct, the Lambda scaffolding or the S3 scaffolding and governance constructs to make sure I'm using the right stuff. I just use the Service Catalog product. And I can combine these together in a CloudFormation template. What we've done is we've worked with the AWS CloudFormation team to create the ability to reference one product from another product from within a CloudFormation template. So you could create outputs from one of these products and reference those as inputs to another product. So for example, if you have a Lambda referenced here and you have an API gateway and the API gateway needs to know about that Lambda, whatever that API gateway needs to know, you can specify as outputs of that Lambda. And when you launch the API gateway from within this template, you can reference those outputs and use them as inputs into your API gateway. So a very flexible way to create more complex product configurations. And here's a little bit more detail about what this would look like. So you can define your Lambda in CloudFormation. You can define your API gateway, and then you can connect your Lambda to the API gateway. And I've highlighted that here. What we use is the CloudFormation getAt command. So that gets the attribute that's been specified, and that gets used in the provisioning of that product. So the net result of this is that a developer could create a very simple serverless stack simply by combining two Service Catalog products. And with that, I want to talk about a new feature of Service Catalog. And this has launched at reInvent on December 3rd. And we think it'll provide a lot of benefits to our customers, especially ones that operate in AWS environments where they have many applications that are being developed and running. So let me tell you a little bit about why we came up with this. We talked with a lot of our customers, and there's some consistent things that they said. They said, look, it's easy to provision resources on AWS. In fact, Service Catalog provides a way to do that in a self-service manner. And that's great. We love that. But what I really need after that is a way to collect all of those resources in the context of what I call an application. The other thing I'd like to do is add more data to my applications. So metadata like who owns this application, who's on call. I need a flexible way to do that. I could use tags, but there's a limit on tags and the key value pairs. And I have data that might be maybe a little bit more unstructured or be better represented in arrays or lists, for example. So we've listened to our customers and we've implemented this feature that enables a couple of really important things. One is context. So now I can have application context for the AWS resources that I've provisioned. It also opens the gate to interoperability with other AWS services and AWS partners and third-party software. So I'll get into a little bit more about how that applies in a bit. And it helps you maintain application lifecycle. By knowing the context of your resources, what application do I belong to, you can make informed decisions about what the appropriate operational actions are for that. So with that, we announce Service Catalog AppRegistry. And it's a way to define and manage your applications and metadata on AWS. Customers can create an application definition. They can use AppRegistry to maintain a single source of truth for their resource collections and metadata. And you can get application context for your resources. So here's what that looks like. So what we've done is we've created an application object within Service Catalog. By the way, I should mention that AppRegistry, although a feature of Service Catalog, does not require you to use Service Catalog as your catalog of products. You don't have to provision through Service Catalog. You can use AppRegistry independent of that. So perfectly fine to do that. This application object, when you create it, you provide a name and a description, and it's a placeholder that you can associate other things with after you create it. You can see here we've shown resources and attribute groups. So at launch, we're supporting resources, specifically CloudFormation stacks that you can associate with your application. And I'll give some examples of how you can do this. And then we have a new construct for Service Catalog that we call attribute groups. These are unstructured JSON files, and you can associate one or more of these attribute groups with your applications. You can even reuse them. So you could create an attribute group for your corporate information, for example, and associate that with all of your applications. Or you may have specific attribute groups that you create and associate only with one of your applications. And I'll provide some examples of how we see this being used by customers. Now, this doesn't require you to restructure what you're already doing on AWS. It's built on top of familiar AWS constructs. So at the lowest level, we're building on top of AWS ARNs, tags, and policies. The next level of abstraction are AWS resource collections. As I mentioned, with launch, we support CloudFormation stacks, and then we layer on this application level abstraction on top of all of that. And this is, again, a really useful conceptual construct for customers to aggregate their resource collections and their metadata around an application. So let's get into a little more detail about what you can actually do with Service Catalog AppRegistry. First, you can create your application. As I mentioned, you provide a name and a description. You can also associate resources. So these would be your CloudFormation stacks. And then you can create attributes and associate those attributes. So a couple of very simple gestures that enable a potentially rich shaping of your application description. So once you have defined your application, associated your resources and your attribute groups, what else can you do with it? Well, you want to get information about it afterwards. So you can list your applications and attribute groups. You can get application details, and you can update, disassociate, and delete. So this gives you full capabilities to create and manage throughout the lifecycle the resource associations and metadata, and then you can delete it when you're done, or you can keep it around for reference. So I've talked a little bit about this application registry and the definition of applications providing context for resources. So again, if we go down the stack here, at the top level is applications, then your resource collection stacks in this case, and then at the lower level, the resources themselves along with the AWS constructs like tags. So as an administrator or potentially a business unit owner or IT manager, I can list my applications. And then I can understand which resource collections are part of that application and what metadata applies to that application. And then I can go into other AWS services, for example, CloudFormation, to see the list of resources that are in a particular stack. And I can look at or use other AWS services like Systems Manager to perform operations on those resources. But I do that all knowing the application context of those resources. Similarly, from a bottoms-up view, if I'm an IT operator and I'm looking at the EC2 instances that are provisioned, I can look at the tags, but I may want more context in order to know what to do with a particular EC2 instance. With this, I can go back up the chain and know what application that came from. So, I may discover that this EC2 instance is a production instance that has a specific recovery time objective and a set of on-call personnel that I can call to discuss what's going on with this resource and what I might want to do with it. Or it could reference runbooks in particular for production instances and help the operator understand what they should do in that case. And here I've provided a sample application definition. This is by no means prescriptive. It really is up to customers to define how they want to describe their application shape. I'll walk through this particular example. So in this example, I have three environments. I have a development, a test, and a production environment. In my development environment, I have 4 application instances. Maybe I have 4 devs and they're each working on different aspects of the application, maybe the UI, maybe database connections, maybe some other backend services. Maybe they're migrating portions of the application to serverless technologies, whatever they're doing. And there may be some application management infrastructure that's associated with that development environment. It could be one or more pipelines that define how code gets from a code repo and onto AWS infrastructure. That can also be part of your AppRegistry application. As long as it's described as a CloudFormation stack, that can be associated with AppRegistry. I may have a test environment and a large test instance that I'm running load or scalability tests against. And then I have my production instance or set of instances. And here I have 2 stacks depicted. Maybe those are in a failover configuration. And all of these together can be associated with an application in AppRegistry. Similarly, you can have multiple attribute groups. Here I've depicted 4 attribute groups for this particular application. And I might have one attribute group that's my corporate info or business unit info, or maybe both. And I may have other attribute groups that maybe have specific information, in this case, not for a particular stack, but maybe for an environment. So I may have an attribute group for my dev environment, my test environment, and my prod environment. Now, during updates of these application instances, you can also update the metadata. So one of the patterns we expect to see from customers is that they will automate the updating of the metadata so that the metadata always has the right information at the time of provisioning of any updates to any of these stacks that they have in their application. I've also depicted here on the lower right an application tag. So since application is an object on AWS, it has an ARN and it's taggable. So you could apply your own tags to that and use that for whatever purpose you want. So I'm going to pull this back around to cost visibility. And now that you understand what AppRegistry does and what an application is in AppRegistry, you can probably jump ahead and see by applying tagging to this application, I can gain cost visibility. Now, not just at the service catalog product level or portfolio level, but I can gain it at the application level. And by doing that, it provides this additional abstraction, which could be really important for business reasons. As an IT manager, I may want to understand how much is my widget sales tracking application costing me, and you may even want to look at it across different dimensions. So AppRegistry gives you the service primitives to be able to define that yourself, and then to leverage other AWS services like AWS budgets in this case to provide that application level visibility, in this case, across the cost dimension. So with that, I'd like to talk a little bit about how AWS partners and software vendors have received AppRegistry and some of the use cases that they see. So a couple of our partners see value in collecting and segmenting customer workloads by application and doing this in AppRegistry. They will add metadata like who owns the application, what the on-call rotation is for that, maybe the state of the application for migration. So a lot of different ways they see of being able to provide value to their customers by using AppRegistry. Another use case that we've run across is that migration use cases become simpler. So as you discover and collect your on-premise applications in preparation for migration to AWS, one of the things you can do is take that metadata, put it into AppRegistry as part of an AppRegistry application, and then when you migrate those workloads, they will become AWS CloudFormation stacks. Those can be associated. And then as you optimize those applications on AWS, you can continually update the metadata or even maybe add new attribute groups for different important migration and modernization stages and look at your progress along the way. Some of our AWS software partners for application observability see utility in this too. So some of these vendors already have the notion of an application, and they see potential use cases for applying their definition of an application in AppRegistry and then letting customers build additional metadata on top of that, which could then be leveraged by the software partners to provide even more value back to the customers. So by having visibility into maybe some of the business unit data, these partners can then apply application observability in a business context, not just an AWS resource and deep IT operational set of observable items, but actually raise it up to the level of business visibility. And the last topic that I want to touch on is by providing AppRegistry and this concept of an application, along with the tagging associated with an application, we provide what I call an AWS service principal primitive that lets other AWS services build on. So I've given a couple of examples here. So AWS Service Catalog now has AppRegistry. CloudFormation could auto-register stacks with AppRegistry, providing that telemetry regardless of whether you provision through Service Catalog or CloudFormation. Similarly, for IT operations on applications and application resources, AWS Systems Manager can build on top of AppRegistry to provide that application level context for any of the resources that are managed in AWS Systems Manager. So this holistic visibility of resources in the context of applications becomes really valuable. And by having other AWS services built on top of AppRegistry, we provide customers with additional telemetry on their applications throughout the application lifecycle, keeping the set of resource collections and the metadata consistent and up to date.